Good evening, everyone. I'm Suyash. This is Nakib, and we are going to present our project Whazzat. What's that? So Whazzat is the ultimate product discovery assistant. So we've all been in a situation where we have a vague idea about a need, but we don't really know what specific product to buy. This is where Whazzat comes in. So you can ask it for something like something for a home workout session, and it will show you links for yoga mats and resistance bands. We also wanted to see if we could train the Llama 2 model on the free version of Google Colab. So coming to the data, our gathered data set was a mix of data collected manually and data synthesized using GPT-4 and the tool mostly AI. We collected 1,000 data points, and this data had a lot of repetitions and redundancies. So we cleaned it of these redundancies, structured it so that the model could be fine-tuned on it. So this is a sample of one data point which has the user description along with the relevant product. So as I mentioned before, we use the Llama 2 model. We use the Llama 2 model, chart model with 7 million parameters. It was fine-tuned using quantized low-rank adapters as a parameter-efficient fine-tuning method. In this, we load the model, quantize it to 4 bits, freeze the parameters, and we add adapter weight matrices on top of it. These matrices are what is then trained. So this reduced the model, like the number of parameters to be trained by a factor of 512, along with a lot of hyperparameter tuning and enabling double quantization. We were finally able to run it on the free version of Google Colab. This is the plot for the training and validation loss, and as you can see, around step size of 50, the model converges and gives us a good fit.
So now let's look into the component architecture. So we build a user interface on Gradio. So user can actually input the prompt, the problem that they are having. Based on that, our fine-tuned Llama 2 actually gives output some product names, and we actually search those product names in an API. And finally, we sort those products and actually show them in our interface. While doing that, we also send it to GPT-4 just to check a relevance check. And GPT-4, we have prepared a prompt, and we ask GPT-4 whether all the products are relevant or not. If all the products are relevant, it gives a positive output. Otherwise, it gives the relevant products and irrelevant products. So we found that GPT-4 actually gives a better output in some cases, in some of the vague wordings. We'll come to that example later. So for an example, we tried something to relax after a tiring workday in Amazon, and as you can see, there is no results coming from Amazon.com. But if you give the same output in our Gradio interface, you can see that it has given 5 outputs: scented candle, aerotherapy, essential oil, fuzzy blanket, relaxing music, and massage chair. And based on those outputs, we have got these products from the API. So we are showing the product photos, ratings, review, price, as well as Amazon link. You can click that and you can go and buy that product from Amazon itself. And the product output that our fine-tuned model actually gave, GPT-4 actually gave a positive response to all those product outputs. So now let's come to the learning and our future scope. So basically what we found that this model actually retains the pre-fine-tuned knowledge. We gave certain inputs to it, certain prompts to it, and got the proper outputs from the model itself. Then we feel that by tweaking the training parameters, we can actually update. The model can actually perform better. Also, the user feedback we can create a user feedback loop. When we are showing the output, the user can actually mark whether the product is relevant and irrelevant, and we can actually use that to train the model again. The product sorting can be improved a bit. And finally, there is a 2-minute time our model takes to actually give the output. But if we can use merge and unload, there is a function to actually do that. Then those adapter models and the base models can get merged together and give a final output, which we can use, that can reduce the inference latency a bit. So that's about it for our presentation. Thank you so much. Hope you liked it. If you have any question, we're happy to answer.